Hey everyone, welcome to lesson number 4. We're going to be looking at determining angle measures from trigonometric ratios. This is first part's just kind of a review. We're looking at angle measurements in degrees from the primary trig ratios. So looking at sine, cosine, and tan. And just remember that if we're looking for the angle, we're going to have to do that determined by the sign of the ratio. And so that's where we kind of looked at the concept of add sugar to coffee, where in the quadrant 1 we would have all of our ratios that were positive. Quadrant 2 we would have our sine ratios that are positive. In quadrant 3 we would have tan ratios positive, and in quadrant 4 we would only have cosine ratios that are positive. And so then we would be able to then find out what the angle measurements were if we were able to determine the reference angle. And the reference angle was always between 0 and 90 degrees. And then we would draw a rough sketch in the appropriate quadrant depending on the sign of the ratio to determine where that reference angle actually was located. And we always try to express that with an absolute value, so no decimals for our given quantities. And then we would determine the rotation angle using the reference angle and the quadrant that it was in. And don't worry, we're going to be reviewing this if this is something that you forgot. So let's look at class example number 1. We want to complete the following to solve cosine theta is equal to negative 0.5, where the angle theta is between 0 degrees and 360 degrees. So first of all, this can be in quadrant 2 and 3, because if we add sugar to coffee and my ratio is negative 0.5 and it's cosine, we know it can't be in quadrant 1 or 4 where cosine is positive. So it's 2 or 3. It's gotta, if it's 0.5, then one thing remember you can do is you go cosine 0.5 would, if I want the angle, I want the inverse cosine. That would be a reference angle of 60 degrees. So we got a reference angle of 60 degrees. And if this is in quadrant 2, then my rotation angle is going to be, in quadrant 2 is where my sine ratios are positive, are 180 degrees. Subtract my reference angle of 60 degrees would be 120 degrees. In quadrant 3, so quadrant 3 is where my tan ratio is positive and my cosine ratio is negative, is 180 degrees plus 60 degrees, or 240 degrees for our angles of rotation. The last thing we would need to do is, and actually I should write out how I got this reference angle. This was the inverse cosine of 0.5. Notice how I didn't say negative 0.5, I just said 0.5. And that's because the negative sign is really just to show us where this angle is located. And so now what we need to do is just do a rough sketch of where this angle is. So 120 degrees is around here, where this is my rotation angle of 120 degrees. 60 degrees is my acute reference angle. And then I have another 60 degree angle for reference, but that is a rotation of 240 degrees. Now, given that sine squared theta can be written as sine squared theta, or sine theta squared can be written as sine squared theta, solve the equation sine squared theta, or sine theta squared, is equal to 0.5. And again, we're looking for these intervals of theta between 0 and 360 degrees. Well, let's start with sine, and let me move this up a little bit. Sine squared theta is equal to 0.5. Now, we don't want to solve for square theta, we want to solve for sine theta, in which case we want to take the square root of 0.5. Now, when I take the square root of 0.5, I'm going to get plus and minus the square root of 0.5. Now, if it's plus and minus the square root of 0.5, this means that we're going to have this in all 4 quadrants. Right? Because I took the square root, we have the positive and we have the negative. So of all 4 quadrants. Now, if I have the positive and the negative in all 4 quadrants, if we take a look at what the inverse of sine of the square of 0.5 is, we get, and so this is what I input it into my calculator. So inverse sine, square root of 0.5, close my brackets, I get 45 degrees as my reference angle. So my reference angle is equal to inverse sine square root 0.5. This yields 45. This equals 45 degrees. So if we know that we have 45-degree reference angle in every single quadrant, then what that means is my angle theta is going to be 45 degrees in quadrant 1. In quadrant 2, it's going to be 180 degrees minus 45 degrees. In quadrant 3, it's going to be 180 degrees plus 45 degrees. And in quadrant 4, it's going to be 360 degrees minus 45 degrees. And what this is going to come out to is we got 45 degrees, we have 135 degrees, we have 225 degrees, and then we have 315 degrees. And these are going to be at, it's going to look something like this for my respective angles. All right, now if we were to angle measure in degrees from reciprocal trig ratios, so since there are no calculator keys for cosecant, secant, or cotangent, we must, I think I skipped it. Oh, no, sorry, I did not. Apologies. So since there are no calculator keys for cosecant, secant, or cotangent, we must write the reciprocal ratios in their primary form. So for example, to solve cotangent x is equal to square root of 3, we have to rewrite this in the primary form of tan x is equal to 1 divided by square root of 3. So we want to solve cotangent x is equal to the square root of 3, where x is between 0 and 360 degrees. So first of all, we're going to have to rewrite this as tan x is equal to 1 over the square root of 3. And since this is positive, we know that this will be positive in quadrants 1 and quadrants 3. And if we take a look at our reference angle, so the inverse tan of 1 divided by the square root of 3, we have a reference angle of 30 degrees. And x would then equal 30 degrees if it's in quadrants 1 and 3, and 180 degrees plus 30 degrees. So x is equal to 30 degrees, and x is equal to 210 degrees. So in quadrant 1, we'll have 30 degrees here. Quadrant 2, 30 degrees will be right here. And there's my first rotation angle, and my second rotation angle would go way over there. Now, determine the measure of x to the nearest degree, where x is between 0 and 360 degrees. We have secant of x, and now secant is the reciprocal of cosine, and this is negative here. So as a cosine ratio, we have cosine x is equal to negative 1 over 1.2631. And if it's negative, this is going to be in quadrants 2 and 3, because it's a cosine. It's the reciprocal of a cosine, and so we know that's in quadrants 2 and 3. With a reference angle of, so second function cosine, 1 divided by 1.2631, and I get a reference angle of 38 degrees. It's 38 degrees. So then x is equal to 180 degrees minus 38 degrees and 180 degrees plus 38 degrees. degrees. So x is equal to 142 degrees and 218 degrees. Last, if we want to find a similar procedure, we can find the angle measured in radians from our trig ratios as well. And so if we're looking for the measure of radians, we're going to use the similar procedure. So step one, we're going to determine the quadrant the angle will be in just by looking at the sine. And then step two, we'll determine the reference angle. And we're always looking between 0 and pi half, or pi over 2. And we'll draw a rough sketch of the appropriate quadrant, and same thing using our second functions for each of these as well. So first of all, let's determine the rotation angle using the reference angle and the quadrant. So quadrant 1 rotation angle is equal to the reference angle, and this is stuff we hopefully already know. And if not, I would just review this page here. But in each case here, let's determine the value of theta to the nearest hundredth of a radian. So I have cosine theta is equal to negative 0.5, where theta is between 0 and 2 pi. So if it is negative, again, we're going to be in quadrant 2 and 3. And if I have a reference angle of 0.5, if I were to type it in like this, I get 60, and this is in degrees. So what we have to do is we have to make sure that we go down to mode and change it to radians. So now when we type in 0.5, I'm not going to get 60 degrees. I'm instead going to get 1.047. So my reference angle is equal to 1.047, and there is some extra information there. And to get the actual angle of theta, I'm gonna store this as alpha A. And now what I'm gonna do is, because this is in quadrants 2 and 3, this is gonna be pi subtract 1.047 and pi plus 1.047 with extra information. And so the angle that we're going to get to the nearest hundredth is going to be pi subtract alpha A, which is 2.09. And we also have pi add, which is 4.19. All right.